me some electronegativity so everyone can have the right values in their notes so they judge me less harshly. I like the electronegativities of sodium, oxygen, hydrogen, and carbon.
Sodium is right, 0.9. Oxygen is 3.4. Hydrogen is 2.2. Carbon is 2.6.
Okay, so the reason that Emma fixed that for me is because I wanted to say the biggest electronegativity difference here is between sodium, oxygen, and here is between oxygen and hydrogen. So this is where the chemistry is going to happen in an alcohol, the most polar bond. This is where the chemistry is going to happen in sodium hydroxide. That's why they behave differently. So if Brecken is asked what is the functional group in methanol and he writes down hydroxide, 0 marks. It is not an ionic bond. You must write down the word hydroxyl. Now YL is very important. It's the same YL we have in methyl and ethyl. So it feels organic-y. We'll have carbonyls, like we'll have lots of YLs. IDE means I'm an ion, and we are not going to have ions. Polyatomic anion. Yeah.
Why do we need to know the electronegativity?
Because I was trying to convince you that this is an ionic bond because the huge difference in electronegativity here.
Oh, okay.
These are all covalent bonds. The most electronegativity difference is here, so that's the polar bond. So the reactivity will actually be different in methanol. It will be about removing and adding an H here. It will not be about removing the OH on the whole. I mean, we'll have that mechanism, don't worry, but they behave differently. Ionic, covalent. I would settle for that. Amarachi, what?
This is still related to like the structural isomer stuff?
So I'm just telling you why it's a hydroxyl group that I circled in my structural isomer on the left. So I'd like to name these two guys.
That whole thing is an alcohol and that one.
Yes, I have 2 alcohols on the left and I have 1 ether on the right.
Aren't all terminal isomers?
Yes. Yes. Perfectly said. Okay, so the guy on the left, what's the longest chain? So it's propane. But the most important thing here, because there is something interesting now, is an alcohol. So what is the suffix that I associate with alcohol? Ol. But I need to distinguish between these two. So how would you suggest I distinguish between these two? They have 3 carbons. You mean, that's not what you mean?
The number labeling of the carbon.
Yeah, I'm going to number the carbons, and I'm going to tell you where that OH is. So I'm going to start on the side that's closest to this new interesting functional group I've got. And so this can be 1 propanol or 2 propanol if you're old school.
And the top alcohol is behind the second one.
Yeah, we're going to save that. But you're right. Rita's not here, so I feel okay with maybe ones different ways. The IB would officially refer to these as propan 1-ol and propan 2-ol. Yep, OL is one of the things I write funny. Welcome to my world. I write the word mole more often than everyone else in this room.
Wait, what is that?
For Leo.
I'm a Leo, so that's good, right?
Oh, it's just OL, yeah.
Oh, it's an OL?
Yes, that is an O and an L next to each other. My handwriting is special. I write the word mole a lot. So when I write mole, I know it's been a minute, but that's what I write. You go back in your notes, you'll find mole.
Sign for all representatives.
Yep, looks a little bit like a capital Omega, looks a little bit like a Leo.
Is it supposed to be like that?
Dude, you just have to write the letters O and L.
Okay.
This is now a discussion on my penmanship. The guy on the right, what's the longest carbon chain?
2.
So it's an ethane. And in front of it, what I write is methoxy. This has one carbon and that ether group, that oxo functional group. And so that's referred to as methoxyethane. Methoxyethane would be written in a problem statement, but there is no naming of ethers in IB assessments. There's understanding that that looks like an ether. There's identifying it as an ether, but for whatever reason, they don't have you name it. My suspicion is that it's because I grew up calling that ethyl methyl ether. If you've ever used ether in a hospital, you never used ether in a hospital, but like if you went back 100 years and we tried to, put Chloe out, that would be diethyl ether that we used to make her anesthetized enough for surgery. And since no one I've ever met has read the Cider House Rules, I'll just tell you the doctor is quite addicted to the ether. Plot point, Tobey Maguire. Such a good movie. Right, you do not have to name an ether. So the internal is the ether, we don't have to name them.
Don't have to name it ether.
You don't have to name an ether, but you do have to be able to read the name of it. It's like in a little bit of a Twilight Zone.
But it's up here.
So keeping this in mind, having one oxygen and having both an internal and a terminal way of describing it, what I'm going to do is I'm going to take away 2 hydrogens. See how effectively I did that? When I take away those 2 hydrogens, what I have in mind are these 2 structures. A structure with a double bond O at the end, so this is again going to be my terminal case, and a structure with a double bond O in the middle. That's going to be my internal case. So these 2 are another set of structural isomers. They have this general formula. I can put the business at the end, or I can put the business in the middle. When I put the business at the end, this class of compound is known as aldehydes. When I put the business in the middle, this class of compounds is known as a ketone. Audrey, help me with smelly in Mandarin that sounds like cho. What does it mean, Audrey? Huh? Stinky?
I don't know, Chloe is here, like.
In Cantonese, you say tao tao.
But I don't want to say that.
What do you
I want to say cho.
Can you ask Chloe?
Chloe, can you help me with cho that means stinky?
Yeah.
How do you say it?
Oh.
Cho. I didn't do better. Aldehydes are known for having a really bad smell. I call this group cho. I'm trying to say what you just heard Chloe say. I will call them chos. Dude, tones are just messed up. 2 layers of accents is 1 layer too many, if not 2. Dude, it's just wrong. Like no one sees a question. I can't even spell pho right now. No one sees a question mark on top of something. It's like, oh, I'm gonna know how to say that. Like there's a question mark. Like no one knows how to say it. I made it up. I don't remember.
There's like one connected to the O and like one on top.
Yeah, I tried. I know there's a question mark on the O. Okay, so this is my question mark, and this is just the little asterisk, like the apostrophe.
Yeah.
So this is the letter, and this is the syllable.
Wait, so then that's known as what?
Just the letter.
Okay.
I mean, ignorant, but like ignorant a step further than most people who can't speak Vietnamese, right?
So for the ethers, it has to be inside of the carbons, but this one, it
So it
just
has
has
to
to be in the
be,
middle.
it has to have CHO
Yes.
for it to be.
So I would describe that oxo like in the middle. I'm going to describe this as in the middle. It's got carbons on both sides. You just have to be able to recognize this. You don't have to believe in my internal and external thing. These 2 are structural isomers of each other. If I wanted to name the one on the left, the cho, as I like to call it, count the longest chain, prop. All right, down propane, can you find me the suffix I associate with aldehydes? how differently I write an A and an O? Because I write my O so goofy. It's because it matters. It does. Like, to keep this going, I'm going to use the suffix on the right for a ketone. What is the suffix I associate with a ketone?
One.
Own. So aldehydes are als and ketones are ons.
So,
Wait,
why is it not just propane?
Because it's propane, we just remove the E. Just like propanol, we just remove the E.
So is this like an this is still an alkane?
It's an alkane with a functional group on it, a ketone.
It's an alkane, not an alkane, right?
Yeah, we can make propenone if, oh, we can't actually make propenone, but we can make pentenone if we wanted, if you would like to.
It has to be,
wait, this is the double bond has to be.
So she's worried about this A. So this A is saying that these are all single bonds. So if Rami wanted to name that molecule, she might have to call it the butene O. And then tell me where the ene is and tell me where the O
the
is.
double bond thing only matters if it's three carbons. And the difference between an aldehyde and ketone is just.
An aldehyde has to be at the end. It has to be a CHO. It has to smell bad.
So these are all still alkyne.
None of these are alkynes. These all have single bonds between the carbons, so they are still got this A in here. I would not describe this as an alkane. As soon as I put the oxygen in there, I would describe this as an aldehyde. So we normally describe it by the class that's like the most important. So if you look at that list, it's telling you about importance of the highest one up. And so that's an imperfection in this system. How do you think I might call something that had a lot of carbons and this double bond? We call this group a carbonyl. Carbonyl. You're gonna meet people that call it a carbonyl. I judge those people, I'll be honest, but it's acceptable. Carbonyl or carbonyl.
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 What is this?
So I'd like to know how you might consider naming this.
Wait, what is?
Okay? Brecken says it's a ketone because he sees this carbonyl group and it's not at the edge, it's not a CHO. So it's a ketone, it's not an aldehyde.
Wait, what is that? Carbonyl? What are we?
So both the aldehyde and the ketone have a C double bond O in them.
It's a pentanol.
So that is referred to as a carbonyl. An aldehyde has the carbonyl on an edge. That's what makes it an aldehyde. A ketone has a carbonyl in the middle. And so my friends were counting this. They found that the longest chain was 5, so they thought this was a pentane. Then they were going to shove an one on the end because it was a ketone. So this is a pentanone. The question is, are there other pentanones?
Probably. Yeah.
So Rami says that she can envision that one. That's a different molecule. So how might I discriminate between him and her? We will call this 2-pentanone. We will call this 3-pentanone.
Does Ivy put the 2 in the middle of the word? Wait.
I'm waiting.
Pentanol.
Okay, so if we put it in the middle.
Both of these are considered the middle. So that's why I called it internal. I wasn't trying to go for the arithmetic mean. There are two cases. You're on the edge, that's terminal, or you're not on the edge, that's in the middle,
Okay, so
internal.
middle just means not on the edge.
Not on the edge. That's why I said internal when I started. Like I had tried this before. So we do use numbers in this system. I'm just trying to use a few carbons so that you don't panic too much. You'll see I have things around the room for you to name. I can't wait till we get there. God, I hope we get there.
15.
So now instead of having one oxygen, what I'm going to do is I'm going to have 2 oxygens.
I love oxygen.
and put that in the middle.
So are these new structural isomers?
These are a new set of structural isomers, so I changed that formula. Now there are 2 oxygens in it. When the 2 oxygens on the end form this group, you guessed it, I call it a coup. That's because when you write the structural formula of this, you write coup. If you go back to propanol, if you wrote the structural formula for propanol before I erased, you write cho. So it's not just for kicks that I call them chos. That's what you physically write down if you're trying to condense the formula. If you didn't put the H in front of the O, do you see how you might read it as an alcohol? So it's very important that that H comes before, so we see it's a cho, we see that double bond there. The molecule on the left, Brecken is telling me that he sees that the longest chain has this group, an ethyl group, attached to the coup. And he's trying to decide if he wants to call this the ethyl with the coup, or if he wants to just look at how long the chain is. He is going to look at the whole chain. So he's going to count 1, 2, 3, and he's going to call this propen. And what is the suffix we associate with carboxylic acids, or coups? Oic acid. Now, if you actually went into the stock room, you'd find that people call this propionic acid in this fine country. Propionic acid. It's not butanoic acid when I buy it from the chemical supplier. It's butyric acid. It smells like vomit. No, you may not use it for your IA. No.
It smells like vomit.
It literally smells like vomit. I had a big fight last year. Someone wanted to use it. I'm like, no, this smells like vomit. We don't have a hood. Like, no, it's not good for me. Now the guy on the right, what is the longest chain that you see? So you hopefully see a 2 chain and a 1 chain. So I'm expecting that the resulting compound is going to have a meth and an F in it, broken up. But there are actually 2 ways I can put this internal. Do you see that both of these contain a kook? I don't care. Y'all laugh at me all you want. This, my loves, is a kook. We'll refer to it as an ester when we're out in polite company. But when we're learning it, we're looking for that kook functionality. So both of those have the same formula, C3H6O2, and both of them have this kook instead of a coup. Both of them are internal, so they're both esters.
Wait, so that group is called an ester, or those molecules?
That class is called an ester. That group is called a carboxy.
The class is
So the class over here is carboxylic acid. This group is called our carboxylic acid, a carboxy group. Carboxyl. There we go.
And then what about for the one on the list, right?
I'm going to call it carboxyl too because I don't have a better answer.
And then the class is
Ester.
ester.
That 100%. So we need a way to name the 2 structures on the right. So we will never use the prefix because we don't hate each other. Yeah. I'll show you what this means. We'll figure it out. First we're going to name it IB style, then we're going to try to figure out what's on this fine poster I found. way we're gonna do this is we're gonna think about how one might go about making an ester. An ester is often considered to be an organic salt. And so if I had to make a salt, what I would do is I would take a base like sodium hydroxide, and I would add it to an acid like nitric acid. Can you tell me what the products of this would be? Water and NaNO3?
Yeah.
Okay, so let's think about how we name these things. I'm going to name this one kind of funny. I don't know. I got it. So on the left I have sodium hydroxide. I don't have a real good analog for that. And nitric acid. On the right I have water. My favorite, I'm good at that one. How do I call this compound in sodium nitrate? So what's the connection between nitric acid and nitrates? Nitrate is the conjugate base to nitric acid. All ic acids become ates. All us acids become ites. All hydroic acids become ides. Quinn, you're killing me. You agree if this is hydrochloric acid, you would call this sodium chloride? Don't you?
Yeah.
Do you agree if this was nitrous acid, you would call this sodium nitrite? And then you'd agree that the IB doesn't care about these words because we're too cultured and people have new names for this, and who cares? I just want you to appreciate that's the conjugate base. That's the acid, this is conjugate base. Okay? So what I'm going to do is I'm going to come in here, instead of sodium hydroxide, I'm going to put in methanol. It's going to take on the role of this base. And you know, just for a lark, I'm going to call this methyl alcohol. I don't know. At least you'll see that on the label. Is that its official name? No, we would call it methanol. But again, if I pull it out of there, it's going to say methyl alcohol. So I know I'm like a little bit fast and loose on this. But that's methyl alcohol just for a moment. And I'm going to mix it with this. What might you call this molecule? It's a coup. I heard it. I hope you're calling it ethanoic acid. And so when these two things come together, we're going to make Ramey's water, but we're also going to make, let's see, we take the first word here, so the first word here is going to be methyl. And then we write down the conjugate base to ethanoic acid. What's that? 8, ethanoate. There are 2 C's in the longest chain. The coup C counts. Just like in propanoic acid, the longest chain was 3 because I included the coup C. So this molecule is methyl ethanoate. If I were to draw it, what I'm doing is I'm taking this H and this OH away, and I'm making a new bond right there. So that is methyl ethanoate. So if you look at the molecules that I drew, what we're going to do is we're going to find the coup, and we're going to name what is bonded to the single bonded O. So here's the single bonded O. How would you call this 2-carbon chain? Ethyl. So we're going to call that ethyl. And then we need to think about what acid would have looked like this before we took away the H. So what is this the conjugate base to? So look for that single bonded O. Attached to it is an ethyl group, so ethyl is the first thing I write down. Then I look at the carbon with the double bond. I see how long his chain is. 1, so it's methanoate. Yeah.
There's no H attached to the end of the group there.
That's right. I deleted it when I made the water.
Okay.
No, don't be sorry. So what's the name of the second one here? How would I name this? This is methyl ethanoate. So Audrey was looking at this poster that I made to get things to be better. You can judge whether it does or not. And I'm looking for ester. Less. And it says R-oxycarbonyl. So R refers to a group that is the residue that's attached to this. So you could have a methoxycarbonyl or whatever. So you would be naming this piece, so you call this an ethoxycarbonyl if it was attached to something complicated. So the R group is saying that you have to put the alkyl suffix, prefix there to say how long it is when it's attached. We will never use the prefix. Yeah. Yes. So R always means, I say it means the rest. I think it's actually a German word, so we can ask our German dude, but I'm going to say it's the rest. Okay, so esters and carboxylic acids got a little bit more complicated because you could see that there were a few esters that I could make with just 3 carbons, and naming them was no longer obvious. There's not one chain of 3, and like a location of a thing I could move instead because it's internal, like I kind of want to weep. So what I'm going to do is I'm going to find the single bonded oxygen, and I'm going to name what's attached to it. So here it's an ethyl. And then I'm going to find that double bonded oxygen. I'm going to count how long that chain is. It's 1. So I'm going to write methanoate. Same thing here. I'm going to find that single bonded oxygen, what's attached to it, 1. So I'm going to write methyl. I'm going to find that double bonded oxygen, 2, ethanoate. So it's always blankle, blankanoate, but knowing which is which, I use the single bonded oxygen and the double bonded oxygen in that order. That's everything that has just carbon, hydrogen, and oxygen. So you have done alcohols and ethers, aldehydes and ketones, carboxylic acids and esters. What's my next most favorite element? Nitrogen. This doesn't work quite as elegantly. Welcome to the real world. The first one only exists as terminal.
Is this a new?
This is all new, so we're including nitrogen. I tried to come up with the general formula. You're going to tell me if I counted poorly. This one's easy.
So this is nitrogen removed off of oxygen.
We're temporarily done with oxygen.
So we're gonna
This
combine
only
them.
comes in a terminal variety. This is meant to be the easy one. It's a one-off. You just need to learn what to call this. Hey, I have a carbon triple bonded to nitrogen. That looks like a thingy.
But it's only terminal.
It's only terminal. We call this a cyano functional group. The class is called the nitrile. Yes. The cyano functional group, the class is nitrile. We're going to find that longest chain of carbons is 3 long, so it's going to be propane. And we just put the word nitrile after it. This is propane nitrile.
What does
One
the
word.
FG stand for?
Functional group. This is analogous to a cyanide in inorganic chemistry. So sodium cyanide also has this triple bond.
We don't need cyanide to
No. But a legal question can be, what is a functional group? So it might be a vocabulary term. We don't spend a whole lot of time on nitriles. It's meant to be not bad. I'm only aware of 2 more, friends. Cyano. Oh, 3 more. one-off, straight up flashcard.
What, are these also nitrogen? What is?
Give me a second, and I'll tell you as much as I can. So this is gonna be something of the general formula, CnH2n, oh my God, N, H2n.
And this is the structural isomers.
So those are all structural isomers of something. It's never before been written quite that way. That's correct.
So then this would be the fourth structural isomer group that we're going over.
This is a structural isomer group. This is containing nitrogen. So the nitrile does not have any buddies. It is always terminal. This one, you can see it can be terminal or it can be internal. But when it's internal, it can be like even more embedded. So we actually refer to all of these as the same kind of molecule. All of these are in the class amine. And this functional group is called, unsurprisingly, an amino group.
Can you circle it? Wait, that's NH.
It's the N, it's a single bonded N.
So only the N is the amino? Single bonded N is
A
it?
single bonded N in all of these cases would be amino.
This doesn't have to be triple bond.
That's correct.
Is it
The triple bonded thing is a one-off. If you see a CN triple bond, you know it's a nitrile and you're done. Like, you're happy because it was not hard. When you see a single bonded N, you see that there's some variability. That single bonded N can be at the edge or it can be on the inside. We often refer to these in terms of how many carbons the N is bonded to. So we would call this one a primary amine. You can write primary as a word, or you can write 1 with a degree sign. We call this a secondary amine. And we call this a tertiary amine. So instead of having different words like alcohol and ether, or like ketone and aldehyde, here if I had to say something that would make Margaret know that I was talking about this kind of thing, I would just use the word tertiary. It doesn't have particularly different chemistry. Why does the N only have 3 things bonded to it? That looks confusing to me. Because it always has the lone pair on the nitrogen that I just don't draw anymore. If Quinn said I had to draw a Lewis structure, I would draw it. But if I'm just drawing an organic molecule, I don't have to draw the lone pairs. So just like oxygen has 2 and typically makes 2 bonds, nitrogen has 1 lone pair and so typically makes 3 bonds. To name these 3 things, we're going to use the suffix amine. We're going to look for the longest chain. In this top molecule, the longest chain is 3 long, so I'm going to call this puppy propanamine. Propanamine. But in that secondary amine, the longest chain is only 2 long. So what I've learned so far is that I should call this an ethane, and the suffix, the most important thing I've got going on is this amino group, so I'm going to use the suffix amine. What's interesting about this is that I'd like to tell you where that methyl group is. But if we were to count my chain is 1, 2. And my methyl group isn't actually on this chain. Where is my methyl group? It's on the N. So we call this N-methyl ethanamine. It's not on carbon 1, it's not on carbon 2, it's on the nitrogen, everyone. And the one on the right, everyone I've ever met calls that trimethylamine, except for those of you taking IB are going to call it N-N-dimethylmethanamine. school, we just tell you sort of what's on that nitrogen. So we would call that trimethylamine because it flows well. But you guys are cultured, so you're going to find that the longest chain is 1 carbon long. So you're going to call it a methanamine. But then on that nitrogen, there are in fact 2 methyls. So the position of each methyl is N. So I have to show you where each of the methyls are. And I have to use that prefix di because they're both methyls. So that is N dimethyl methanamine. Yeah, it's a little bit of a wow, right?
So, what you're naming the second line is
Because that's not my current lecture. That's what I grew up with, not right now. I'd be happy to call it that.
I was just confused if you're counting carbons, nitrogen would be closer.
But it's equal, right? So I'm going to choose the longest chain. It's ethanamine, and then I have a carbon on that.
Oh.
I believe we're down to the last one. Everyone, are you psyched? This one is gonna, oh, we're not. We have 2 more. You guys keep lying to me.
Is this one with oxygen or?
This one is gonna be carbon, hydrogen, oxygen, and nitrogen.
Oh, lovely.
That is the excitement I've been waiting for. I feel my whole life. Let's count that together in a minute.
So this is, wait, so this is the 5th one that we're going over on structural isomers, right?
This is not a structural isomer of anything.
What?
This is a new group, right? And he has no partners.
New
So this
group
is
with-
terminal right now. I'll get you there, Sophia, I promise.
There's no interval.
So I am drawing you a terminal one and an internal one. So they both have the formula C2 and minus, I think it's gonna be -1 again. 3, nope. So I get 2 more H's from that. Trying again.
Wait, what?
I don't find the structural formulas helpful at some point, but it's something that's like expressly in the statement that I'm supposed to be able to do. So I'm trying to do it for you. Does anyone remember that from a prettier class? Right, we're trying to make the amide bonds. You guys call it a peptide bond.
Oh.
I'm gonna call it an amide bond.
You'll find that
Two amino acids made water, yeah? This guy, that's a terminal one, we're gonna find the longest chain, it's 3, we're gonna call it propanamide. This group is called an amido group, like amino with a D. This one is sadder, the longest chain is 2, so we're gonna call it ethanamine and anamide. But we got this stupid methyl group on the nitrogen, so this is gonna be N-methyl ethanamide. It's a secondary amide, not a primary amide.
So, wait. Huh? Wait, where did the N come from? N methyl.
So this is my important group. It has 2 carbons in it, so it's an F.
Uh-huh.
It has this cool CONH, so it's an amide. But then I have this, and I don't know what to do with it, so I have to tell you there's a methyl group on the nitrogen. There's a methyl group on the nitrogen.
Oh.
Does the amino group also include the hydrogen, or is it just?
It's really got to be a C double bonded to O bonded to N that has single bonds.
Oh,
So traditionally in biology, an amido group would just be that because that's how y'all, well, it would be that because that's how y'all rock. You have those hydrogens to hydrogen bond and make your alpha helices and beta fluid sheets. Last one, for real this time. Easy one.
Dr. Hennessy, define anti.
Obvious, non-stressful, amido, pain in my butt.
Yeah.
Don't enjoy it. This one, okay. I'll put the hydrogens. I'm so fond of this molecule. What's the longest chain?
3.
I've got a chlorine group at position 2. This is 2-chloropropane. Oh, like I said, I always forget this group of things because it's just not very hard, given all the things that truly are hard, which is a lot. So if you have a halogen attached, you're just going to tell me the position of it, and you're going to use it as a prefix. You will see people call these alkyl chlorides on occasion. Don't worry about it. This is the official naming. That's it. Okay, there are molecules all over the room. It's your job to try to name them. I feel like I should number them so you guys can ask me hard questions, but
Wait.
I also never envision we have 4 minutes.
So, wait.
Let's start with the,
We have 4 minutes left of class.
It's not 11:15, 11:10, 11:15.
What is that one again?
When is class over is the question. 10:15. Right, so we have 4 minutes left. It's called a haloalkane. So it's the class, the functional group is the chlorine. I don't have a fancy word on it.
What is that one?
That one?
Yeah.
It's going to be 2-methyl propanoic acid.
Is that how do you say butane?
I don't know how to name
Butane nitrile.
Butanes?
With the E, butane nitrile.
Is that right?
It's 2-methyl. We have to count from the side with the CN.
Right.
Okay, so my center table women looked at this. They saw that the longest chain was 4 carbons long. It had a nitrile. So they said it was going to be a butane nitrile. They said this carbon is the closest to what's interesting. This is going to define position 1. And so this 2-methyl butane nitrile. That table there was looking at the Cu. They said that the longest chain was 3 long, so it was a propanoic acid. They started counting with the carbon in the Cu. 1 to the left got us to that methyl, so it's 2-methyl propanoic acid. The one in the middle, you can see, is not a not a oic acid. It is a ester. So I've got to start with the thing that's attached to the single bonded O. That's a propyl. And then I've got to see that the thing attached to the double bond O is a meth, so that's propyl methanoate. Propyl methanoate.
Which one is propylmethanoate? That one? Or
This one was 2-methyl butane nitrile.
mm-hmm.